Okay, so sorry about that. Hi there. This is Jacob Nash, Algebra Lessons again, with Unit 3, Lesson 12 on parts of a quadratic function and forms. So please watch Lesson 11 and pretty much the other lessons if you haven't already. So sorry that this unit's so long, but that's just how it is. So here there's different forms, and using certain just like with linear lines, there are different forms. There's different forms for quadratics also, and they can be used to graph easily. So in the last video, we just used standard form to be able to graph, which is not always easy because you have to do a lot of math to find the vertex and zeros, because remember, to find the zeros, you have to either do factoring, quadratic formula, or completing the square. But there's one that's called factored form, which means it's already done for you. Work's already done, so at least you don't have to do that. So here's the different kinds. There's standard form, and here's how to spot out what it looks like. In standard form, there will be something like this: ax squared plus bx plus c, in which a, b, and c already will have numbers filled in for them, and you have to find x if you want to find the x-intercepts. That's what it looks like. So example is going to be the one that we just used on the last video. Terrible. Plus 3x plus 9. So as you can see, 2 would be a, 3 would be b, and 9 would be c. So what's useful about this one? I'll just say U for useful. Useful to find the y-intercept. That's what's already told. You can find other things using equations, but the y-intercept, which is always c. So it's useful to know the y-intercept because y-intercept is c. So then you have vertex form also. Vertex, well, I don't need to write form. Here's what it looks like. It will have a times x minus h squared plus k. So that probably looks weird, but here's what it is. H and k are the coordinates for the vertex. That's why it's called vertex form. So example would be 2 times x minus 3 squared plus 9. So here's the deal with this. So this might seem a little bit confusing, but so these aren't the same equations. I just used the same numbers just because I felt like it. But so the h and k are the coordinates for the vertex, but k is exactly what it is. So we know that k is the y, so that's the y coordinate for the vertex would be 9. And you might think that h is -3, so the vertex is -3, 9, but it's actually 3, 9, because if you think about it, here's x. X would equal 3 if 3 minus 3 equaled 0. So you always change the sign of the h, so remember that. That's something super important. If you're using the vertex form to find the vertex, change the sign of h, but keep it the same for k. So useful for knowing the vertex, obviously, which will be negative k, negative hk. And you might think negative, it's already negative, but if you do negative of -3, that means it's positive, so hopefully that makes sense. Then you have factored. Oh, wrong thing, factored. And factored, let me just do this so it's completely separate. So in factored, it will look like this. Oh, sorry, I forgot to say what A was for this. The A's in these would be the same. And A just means, we'll learn in the transformations, if it's going to be like this, or if it's going to be like this. Like, completely, is it spread apart, or is it together? but we're going to learn about that in transformations. So factored is like this. There can be a, but if there's nothing there, then it means a would just be 1. X minus 2, sorry, 2, what am I thinking? That would be if it was an example. What's the typical thing they use? I think they usually use N and M for this. So that's what that is. An example, which I was already trying to do, would be 2x minus 3, and I'm just for the sake of it, I'll just use the same numbers. And then, well, these actually don't have to be negatives. They could be pluses depending on how it is, but we'll just make it negative for this case. So, why isn't it writing? Okay, there we go. So, what does this tell you? This tells you your x-intercepts. So, it's useful because it tells you x-intercepts. And the x-intercepts are going to be negative m and negative n. Because if you think about it, to find the x-intercepts, then it needs to be set equal to 0, and x, if you're trying to find x, then x is going to be whatever would make that equal 0, which would be 3 and 9 in this case. So just for looking at this, the zeros would be 3 and 9, because all you have to do is change the sign of this. Change the signs of those, and then that's your zeros. So these are your 3 forms, and depending on what you're trying to find to be able to graph it, you need to know what they show you. So let me think. So you have to know how to convert between these forms, but I don't know if that's what I do on this video. Let me see. I don't remember if... Yes, it is what I do. So there's a chart that I have that... Okay, here's how it is. So since I realized I could scroll, I'm just going to scroll this. We'll come back to that if we need to. I didn't even know I could do that. So here's what you do. There's 6 possible things that you might have to do. So if you want to convert from standard to vertex, what do? All you have to do is find the vertex using the equation negative b divided by 2a. So that's what you do. And once you know the coordinates of the vertex, you plug them into the equation, and that's what it is. Now you might think, hey, what's a? Because there's an a in the equation, remember? A. A's right here. What would it be? Well, remember there's already an a in standard, so you wouldn't even have to find that. If you wanted to convert from standard to factored, all you have to do is, well, basically that's what you did when we were doing factoring. You can factor, use quadratic formula, or completing the square, and when you find the zeros, you plug them in to the equation. So all you have to do is find zeros or x-intercepts and plug it in to the equation. And once again, there's an a on that sometimes, so same thing. If you want to convert from vertex to standard, you just have to multiply. And the last lesson of this the last lesson of this unit will be a review, so you would see an example of that problem. So we haven't been doing a lot of problem examples, but that's what would happen in lesson 17. So all you have to do is multiply that out. So you would square everything in here and then multiply by whatever a was and then add k. So you just basically simplify. If you wanted to go from vertex to factored, you have to... This one's not the easiest to do, and you don't really have to convert between these unless that's specifically what you're asked to do on a question, because you could still find the other information if needed. But basically, if you wanted to do that, you would have to first convert to... let's just number these. basically you would do 3 and then 2. Convert to standard and then convert to factored. That's the only way you can do it. There's not really a direct way to do it. So then, if you have to go from factored to vertex, you basically, well, this is another one that's not easy. You have to convert to standard, standard first, which would be step 6. We're going to get to that. And then you would have to do 1. So then, if this one's a pretty easy one, you just simplify. So basically, what happens, simplify. If you want to convert to standard, all you have to do is simplify to where you get a squared. If you want to convert to a vertex form, you pretty much have to be the only way that it will work is if you convert to standard, but you don't have to if it's already like that. And same thing with factored. So there's no way to get from factored to vertex or vice versa without going to standard first, basically. So that's how you can convert between the forms. So that will be it for this video. Thanks for watching, and I'll see you on the next one.